All right, so today I'm going to cover going from exponential form to logarithmic form, but also the difference between just regular bases like, 2, 4, 8, whatever, versus your common logarithm that's base 10 and your natural logarithm that's base e. Okay, so up top we have this first example in exponential form. It says 2 to the power of 5 equals 32. I want to rewrite that expression, that equation in logarithmic form. And in general, the way that I think of it is a logarithm equals an exponent. Okay, so whenever you're asked to calculate a log, on the other side of the equal sign, you should have whatever the exponent is. So a log equals an exponent. All right, so on the left it says base 2 raised to the 5th power equals 32. And I kind of go in a circular pattern like this. So I would write log, and then I need my base, which is 2. So log base 2. So that's going to be a little subscript down there. So log base 2 of 32 equals my exponent of 5. Okay? So log base 2 of 32 equals 5. That equation is saying the same thing as the fact that 2 raised to the exponent 5 equals 32, right? Log base 2 of 32 equals 5. All right, let's look at the second example. 4 squared equals 16. I'm going to rewrite this in logarithmic form as log base 4 of 16 equals my exponent of 2. So you can always kind of go on that circular pattern, start with the base, go on the other side of the equal sign, and then end with your exponent. Log base 4 of 16 equals 2. Okay, so 5 was the exponent in the first equation, 2 was the exponent in the second equation. When we're evaluating logs, when we're saying a log equals something, a log always equals the exponent. All right, so let's get down to this third example where we have 10 cubed equals 1,000, a 1 followed by 3 zeros. So initially, when you write out this logarithmic equation, you would probably, following the same pattern, write log base 10 of 1,000 equals 3, right? And what I wrote isn't incorrect. It's just kind of like poor grammar a little bit, poor math grammar. So the way we're going to fix this is we're going to use a convention that's called a common log. It's redundant to write this base 10 here. It's redundant to write this base 10 here. So I'm going to cross this out and rewrite this as log. I'm not going to write a base, so just log of 1,000. So 1,000 is big, it's not a subscript, equals 3. So you can see that there's no base written down there. In the first example I had base 2, second example I had base 4. This third example, I'm not writing any base. It's implied that that base is going to be a 10. So if you see nothing there, it's implied that it's a base 10. We call this a common log. When you just see the word log with no base written, it implies that the base equals 10. And if you guys look on your graphing calculators, if you go down that left column, you'll see a log button. Try typing this expression into your calculator. If you type log of 1,000 using that log button and hit the enter key, it'll equal 3. It'll equal that exponent. If you try it with these first two examples, type with the log button log of 32, you're not going to get a 5. Log of 16, you're not going to get a 2, because that log button on your calculator where it just says the word log, log, that's base 10. Why don't we write the base 10? What a great question. We've done stuff like this before, you've just never questioned it before. So if I write what's the square root of 25, you guys are all like, oh, that's 5, cool, piece of cake. But really, you knew that this was the square root of 25, right? You're just not used to seeing that little square root written. You're not used to seeing that index of 2. If we write a cube root or a fourth root or a fifth root, we always write the number there. But for square root, we don't write that number. It's implied that it's a 2. In the same way we don't write the 10 under the log, it's implied that it's there. So that's kind of how I think of it. Okay, that brings us to natural logarithms. So base 10 is common logarithms. Then we've got what's called a natural logarithm. So if you continue down on your graphing calculator, if you go on the left side of your graphing calculator, underneath your log button, you'll see an ln button. And right above the ln, if you use the second key to access it, you'll also see this little e to the x doodad. So e is an irrational number just like pi, okay? So e is an irrational number. If I take e and raise it to the first power, which is just the value of e itself, it's approximately equal to 2.72. You guys can access this button in your calculator, the e to the x button, using the second function. Take e, raise it to the first power, hit enter, and you'll get, the full decimal displayed on your screen. But it's approximately 2.72. All right. So e is an irrational base, just like we could say, pi raised to the first power is approximately 3.14. There's another irrational number, right? So e is an irrational number, just like pi is an irrational number. It has a lot of financial applications used in exponential growth models a lot. All right, so focusing on this expression, e to the first power is approximately equal to 2.72. If I want to write that in logarithmic form, at least initially, I might write log base e of 2.72 is approximately equal to 1, right? But just like our common log, we've got this ln abbreviation. So instead of writing it this way, I'm going to rewrite it as ln natural log of 2.72 is approximately equal to 1. So whenever you use that ln notation, again, we're not writing the base, but it's an implied base of e. Whenever you use ln, it implies a base of e. So go ahead and try and type this in your calculators. Use that ln button. So type ln 2.72. You won't get exactly 1 because I rounded that 2.72, but you'll get 1 and change, right? So let's try it again with this final equation down here. E to the power 0 equals 1. Any constant raised to the power 0 is going to equal 1, right? So this is true of 2 to the 0 equals 1, 9 to the 0th power equals 1. So if I wanted to rewrite e to the 0 equals 1 in logarithmic form, because I can see I have a base e, I know I'm going to use my natural log notation. So I would write this as natural log of e, ln of e, sorry about that. ln of 1, that looks better. Okay, natural log of 1 with that implied base e equals 0. And this will be an exact answer in your calculator. So if you use, again, that natural log button, type ln of 1, hit the enter key, and you will get 0.